Welcome to lesson 6. This lesson explains what is a forest plot and the various aspects in a forest plot generated by the Riemann 5.3 software of Cochrane when meta-analysis is performed. Please find examples related to dental research to help you understand better. What is a forest plot? We know of a forest, but what is forest plot? Imagine a forest of same trees with same length and similar foliage. Can we call it as a forest? A forest plot is a graphical representation of the results from the included studies and the overall pooled result. The pooled estimate is determined based on the results from the individual studies. This is a forest plot generated in Riemann 5.3. Forest plot is the scatter plot we get when the effect estimates of various studies are plotted. The right of the picture is the forest scatter plot and is called as the forest plot. Let us understand more about this picture. Before we go through this, I would recommend you to refresh our lessons on binary and continuous data and their analysis to understand this lesson better. The median line in the scatter plot highlighted represents the 1 in risk ratio of the binary data, and this indicates no effect difference between the test and the control. Remember that this will be 0 for continuous data. The x-axis represents the effect estimates and the sides of the test and control. Here it is given as pre-medication and placebo respectively. The highlighted box shows the individual studies and their effect estimates. The smaller boxed area is magnified and shown to the right. The blue square with black line on either side represents effect estimate of the study, and the size of the square, the blue square, shows the weightage contributed by the study towards the overall pooled estimates. The black horizontal line on either side of the blue square represents the confidence interval. In the highlighted study, we find the confidence interval black horizontal line crossing the median line, indicating that the results from that study was not significant and the test and the control in that study were similar. Another study shown by the horizontal line is completely on the right side, indicating favoring the pre-medication group over placebo group. The black diamond shown below indicates the pooled estimate and can be seen that it is completely in the right area with no crossing the median line. This shows that the overall pooled estimate favors the pre-medication group. So overall, we can see that few studies highlighted indicates that the effect estimates showed that the test and the control were similar as they crossed the median line. Here studies highlighted show that the pre-medication, the right side group was better than the placebo. And the overall pooled estimate shown by the black diamond shows that the pre-medication or the test group was more effective. Let us remove the forest plot to show the rest of the section in this and explain it better. The forest plot is removed. The first column is the study name, usually given as author and year. The next four columns are the events and total of test and control of the individual studies as given by the author name. At the bottom of each column are given the respective total of events and total patients. So, the total events in the test was 384 out of a total population of 644 patients, while in the placebo there were 109 events and 390 total patients. The fifth column describes the weight each study contributes to the overall pooled estimates. Agarwal 2010 contributes 5.5%, while the next study, Pariro, has a greater contribution of 16.2%. This is further highlighted by the size of the blue squares in the forest plot. The next column describes the risk ratio and the confidence interval of each study, with a pooled risk ratio and confidence given at the end of the column. The first study RR is 1.14, 0.54, 2.41, while the overall pooled estimate is 1.96, 1.64 to 2.34. Other information is on heterogeneity given as I2 statistics. Here we find the heterogeneity of this meta-analysis to be very low at 4%. Let us see the forest plot for continuous data meta-analysis. In the forest plot of continuous data, the line of known significance is at 0 and each study mean difference is given as the green square with extended black line representing the confidence interval. The pooled mean difference is given by the black diamond and the horizontal extension of the diamond gives the confidence interval. The first column is the study name and year. The next six columns gives the individual studies mean, standard deviation and total patients respectively for test and control groups. So the first study, Thomas C 2004, recorded 0.84 as a mean and 0.32 as standard deviation in the test group, which had 22 patients. The total patients in each group is given at the bottom of this. Next column gives the weight each study contributes to the overall pooled results. The next column gives the mean difference and the confidence interval of individual studies, and if the confidence interval is greater than 0, then the test is more effective. Then the lower end of the column gives a pooled estimate of mean difference. Here, as we can see the values and the forest plot, the pooled mean difference does not show any significant for either group and the black diamond crosses the null line. Thank you. Our next lesson will be on publication bias.